What's up, YouTube? 2024 IstructE exam in January is just around the corner, and I plan on sitting it. I plan on passing it, and I'm going to be sitting a few past papers and sharing my journey along the way in the hopes that it might help a few other people along the way. So, hot off the press is the 2023 February past paper, and I'm going to have a crack at section one of question two of the past paper. So let's have a quick look at what the actual question is. So we are being asked to prepare a design appraisal with appropriate sketches indicating two distinct and viable solutions for the proposed structure, including the foundations. Indicate clearly the functional framing, load transfer, serviceability, and stability aspects of each scheme. Review and critically appraise the schemes and identify the solution you recommend, giving reasons for your choice. Okay, so let's go and check what the client wants. And I'm just going to highlight the key things here. So I understand that a lot of people fail this iStructE exam, and I think a big part of it is sort of like skim reading through these client requirements. And yeah, the first question, they're being told to provide something that's viable. So my understanding is if your schemes don't satisfy any of these client requirements, then they're not viable and you're probably not passing. So we don't want to fall into that statistic. So we're going to pay close attention to what these client requirements are. Number one, an 8-story office block. Okay, cool. Probably not worth highlighting. Number two, all elevations are to be glazed. No bracing is permitted in glazed facades. I'm going to highlight that. So that influences where I'm locating my lateral stability system, and I'm not going to be putting it in the glazed facades. Three, minimum column spacing is 6 meters. Okay, pay attention to that. That's going to affect where I put my columns. And only 2 internal columns are permitted at ground floor. That seems pretty important as well. We haven't looked at ground floor yet, but we will only be putting 2, if any, at ground floor. No columns are permitted outside the perimeter of the building. Not really sure why you'd want to do that, but we won't be doing that either. And the first floor is to be 5 meters above the ground floor. Other floors, okay, that's just kind of the architectural layout that they'll give us in a second. On the 8th floor, the facade is to be set back 2 meters from the lower floors. So that is hinting that there's some sort of transfer structure that you need to allow for. And we will see in figure Q2. We're given some loadings here, 4 kPa on the roof, 10 kPa on the ground floor, 4 kPa on other floors. We don't really have to deal with that in our scheme designs. That's more part of ski section 2 when we do some calcs of our preferred design. Now, site conditions. The site is in the center of a large city. Doesn't really affect question 1, I don't think. I mean, you'd want it to be architecturally pleasing, sure, but I think that more affects when we talk about the construction method and limitations of our proposed design. We've got some basic wind speed, again, that's more calculating loads. Now, the next stuff, the ground condition, this will affect our scheme design and what we propose. So from ground level to 5 meters, we've got heavily contaminated made ground. Okay, so that's pretty important. That's going to affect what we choose here. So the first 5 meters is heavily contaminated. I'm already thinking I'm probably not doing a pad footing in something that's heavily contaminated. And then 5 meters to 10 meters, we've got firm clay, C equals 50 kPa. Now, a catch for the young players, that is not your allowable bearing pressure, that is your cohesion. A good thing with these past papers I've come to understand is just to have a few of those back of the envelope calcs just memorized off the top of your head. So if you're given for fine grained soils C, the cohesion value, you times it by 2, and that is roughly your allowable bearing pressure. If you're given an SPT value, um, with the value N, you times it by 10 for granular soils, and that is your allowable bearing pressure. So we'll keep that in mind when we propose some foundations. And we've got no water discovered. So that means our groundwater table, we don't have to worry about it. Great. And pretty much all the questions always say you can omit the design of lifts, elevators, and stairs. So that is what we'll be doing. Let's go and have a look at what the layout looks like. Um, so eighth floor to roof, that's kind of that 2 meter offset. First to seventh floor, so that's your typical floor plate here. You got your sort of core in the middle, and it's kind of essentially placed. There's your glass in the elevation that we will not be putting any bracing. Um, Interesting that it doesn't glass on this elevation. I think I'm just going to avoid bracing all, because it did say all elevations, so it's a bit unsure whether you can actually use bracing in these elevations, but I'm just going to avoid it and use the core. Ground floor. So the ground floor is a different geometry to the first to seventh floor. And I think it's really important to, a lot to pay attention to this stuff and just understand like geometrically, like what does this mean for your design? So what I'm seeing here is this is the ground floor and it's offset 7.5 meters, which means any load that's sort of in this area here. Say you got a column supporting here. Well, essentially you can't put a column there on the first floor. You can't have a column underneath here on the first floor because then you would have a column here, which would be outside the perimeter of the building, which is maybe what they were talking about when they said no columns are permitted outside the perimeter of the building. So that means we need some form of a transfer structure. So good to note that. And here's an elevation which shows our ground floor. There's the first 5 meters. That 7.5 meters there is just kind of showing how the building sort of steps there a bit, and that's where we'll need some sort of transfery stuff. Then we've got the typical floor plate running up, and then that facade up to the roof that's offset 2 meters that we'll have to design for. So let's get through to the first scheme. Now, yeah, as I said before, I haven't actually sat the exam. I'm just preparing, and this is what I'm thinking at the moment. If you think this could be improved or it's kind of missing something, let me know. I'm going to I want to present my schemes in one A3 and I'll split it into 4 quadrants. And in the top left quadrant, I will be just putting in sort of like these descriptions here where I pretty much just talk about what the scheme is in a brief description. I'll talk about the main structural elements, the floor, the roof, the walls, the foundations, as requested. And then with the big red box, I'll make it blatantly obvious what the lateral stability system here. So what I've prepared for my first scheme is a post-tensioned uh, sort of flat plate floor slab with lateral stability provided by shear core walls. Um, so to put this together, I've kind of, actually I might just split this so we can see the client requirements. So on the right hand side of my screen, we see the client requirements. So we got asked not to put any columns at 6 meter centers. So this is a 30 meter sort of length elevation. So 7.5 meters works quite well because it splits into sort of, what is you got 5 columns there, 7.5 meter centers. So that satisfies the 6 meter centers. And then it's 15 meters running this way, so I just put in 3 columns here, again at 7.5 meters centers. And then when I was putting this together, I realized, oh, they're the 2 columns sort of here and here, which can run through to ground floor. They're the only internal ones. And then the rest of them are just along the perimeter. And as we'll get to later, we'll deal with the transfer stuff. So yeah, as part of my scheme, I really just want, yeah, on my top right corner, I put in a plan. I talk about what the elements are, little legend, and now when I size this stuff, it's just sort of concept scheme design stuff. So I've just gone span on 40 for my post-tension flat plate thickness, so that ends up being about 200. You don't have to design that when you get to section 2. If you do choose this design, you can do some calcs and refine it. Might need to be, could be smaller, could be bigger, whatever. Um, again, the diameter of a column, I think that's like you work out what the axial load is, times it by 20, and that's your sort of like area of the column. So that's how I got 800. And yeah, that's more or less it. Then I put in a section, show the geometry, and this is what my section looks like. And I'm just adding the things that I guess I couldn't capture in plan. So I'm identifying, I'm not designing them, I'm just identifying, hey, I'm aware that I need some sort of transfer element here for that 2 meter offset facade that you had at the roof, as well as that funky 7.5 meter thing at ground floor where you said there were no columns through in the internal. So there's my one that it's allowed on the internal and where my section is. So it kind of steps back there. Maybe this section needs to show a dashed line for a column behind or something like that. But I'm really here just sort of notifying whoever's assessing the exam that, hey, I'm aware that we need some sort of transfer thing for that geometry at the ground floor that wasn't quite the same as the rest of the floor plates above. Now we saw the ground conditions in the first 5 meters heavily contaminated. So I think that pretty much more or less leads you to a deep foundation. So here I've got 1200 diameter board piles. I can't remember how I sized that. That might need some refining. But I mean, I'm just showing that I want my board piles to be about 10 meters, maybe a bit longer to get into um, the mudstone, which we said earlier that the cohesion times 2 is our allowable bearing pressure, which gives us to 300 kPa, which is going to be, yeah, that firm clay is still a bit soft. And then the last two things that I want to illustrate for each of my schemes. So the first one I think is really critical and it ties into what I have in my red box over here is my lateral load path. And I don't think you need to be Picasso with it. It just needs to be, don't be afraid to use color. You just need to illustrate that you understand how the lateral loads go through your structure and down to the ground and that your structure is stable. Because the assessors, before they pass anyone, they want their engineers to make sure that they're confident the engineers understand lateral and vertical load paths. So here's my lateral load path, here's my core wall, load hits my facade, goes through a typical floor plate, acting as a diaphragm. So there's my 200 thick PT slab in the core wall, and I'm just showing a push-pull as my core wall bends into the pile cap, and then I've got sort of a tension, friction pile, and another pile in compression, and that's what's resolving the lateral loads. And then very similarly, I've got a vertical load system here, and I'm not doing it for every floor plate. I think I'm just showing I understand how the vertical loads are getting through to the ground. And again, I'm not afraid to use color. I think it just will make my little sketches a lot more clearer and easier to read, even though this one is not that easy to read. So we got a typical UDL, just a little orange squiggly line along my floor plate here, and I'm showing the bending through the PT slab at the columns. And then my columns and my shear core walls are taking the axial loads. I've drawn a little bending moment in my slab where the transfer is at the roof here. Haven't really shown anything in this section for the what's happening at the transfer down here. And then yeah, my piles will take the bearing at the base. And that's pretty much scheme one. And then I take the same approach when I do scheme two. So just before I so before I get into this, yeah, your both schemes need to be sort of I'm not just switching the material. It needs to be like a distinctly different scheme, and it needs to be viable. So just as before, I'm talking about the description, floor, roof, walls, foundation, and I'm highlighting what the lateral stability is. In my top right-hand quadrant, I plan on drawing, that's where I want to put the plan of my scheme. Now this one, I have decided to use a steel concrete composite floor with a steel braced core to act as my lateral stability. So I've changed the spacing of my columns slightly, but obviously just as before with my client's requirements on the right hand side. My columns are spaced at 6.5 meters, which, yep, satisfies the column spacing at 6 meters. It doesn't really say if it's clear spacing or center to center. I've assumed it's center to center. I might just make an assumption here to let whoever's marking it know that, hey, this is my assumption, just so it's clear as day. Um, so yeah, it's a single span composite slab. This is all, again, just as scheme one, it's just sort of back of the envelope concept design stuff. So I know that a 200 thick probably doesn't even need to be that thick. Composite slab can span 3 meters between my primary beams, which are spanning onto my, sorry, the composite slab spans onto my secondary beams. Secondary beams span onto my primary beams, which are spanning between the columns, and I'm just using color to make it really clear what the load path actually is. Uh, and I've offset the columns from what I had them at scheme one. So I've changed the spacing a bit so they're closer, which sort of, again, this spacing here I like because it aligns with that facade on the roof level, which means we've kind of just deleted the need for one of the transfers at the higher level. So yeah, by setting it off 2 meters, that aligns with this sort of client requirement wherever they spoke about the roof. Oh, yeah, 0.5 here. On the 8th floor, the facade is to be set back 2 meters from the lower floor. So I've set back my columns throughout all the floor plates 2 meters along here and here. Sort of here, see that's 2 meters in. Then we go 2 meters in, and then these columns 2 meters in, and then 6.5 meters ends up being like quite a nice spacing in between. And I don't mind having a bit of a backspan. I think it makes the structure a bit more efficient. Uh, then just as before, add in a section. So here you can see my steel brace frame, and I'm just really trying to highlight the things that you couldn't pick up on the plan. And again, I'm not drawing every one of these. I'm just gonna draw a typical floor plate and plan for my schemes, and a section to illustrate everything else. So here you can see my steel brace frame. I haven't managed to deal away with the transfer that we require due to this geometry. So yep, I've left that in there. I've changed the foundation system slightly because the 5 meter deep, yeah, again, I don't think it's going to be sitting on a pad footing. And I don't think it's feasible to dig out all of that and replace it with sort of like improved ground fill or engineered fill. So I have got driven precast piles, and then I'm going to tie them to a pile cap. Yeah, that's more or less what this section here is illustrating. And just before, I've got my lateral load path. Again, it's just a simple arrow. Just going to draw it here. It doesn't need to be a full UDL across my whole building, or at least I don't think so. Let me know if you think otherwise. And my steel brace frame, I've got the sort of diagonals in tension. I'm using red to show ties. I'm using blue as my horizontal members, in my steel lift shaft as my compression members. And then that finds its way down to the ground, where I end up with a pile cap in tension, another sort of taking the compression, which resolves the lateral load with that push-pull. And again, yeah, I've clearly stated it here. It's a brace coil steel frame used as a central lift shaft. And then just as I did in scheme one, I talk about the vertical load path. So I draw just a UDL on my composite slab spanning in between the secondary beams, and I'm just drawing I could have done this better, but I think they'll understand. The red line's my bending moment in my slab. Um, and the blue lines that are very hard to see here, the axial load, taking the vertical loads down from the floor plate load spans. So if we go from the floor plate, it goes to the secondary beams span onto the primary beams span onto these columns, columns run down to the ground. These arrows are showing that they are in compression. Then I've drawn these little sort of like Stratton ties in my pile caps, which spread the loads to my driven precast piles, which are all bearing at the base in the mudstone. So I think this scheme is viable if we go back and compare it to what all the requirements. Did we, yep, we've kept it as an 8-story office block. We've kept the bracing outside of the sort of the glazed facades, all the bracing and the lateral stabilities in this core. The minimum column spacing is 6 meters, so we leave it at 6, and only 2 internal columns are permitted at ground floor level. We have kept all of the columns. Oh, so yeah, these columns here, and I guess this will be a big thing for section 2, but I've just said that transfer members required. So all of these columns here are going to have to offset because they're kind of internal at the moment. So I might make that a little more obvious. But essentially these columns here are fine. These columns here will need to step out. So I might just copy and paste and just say there's a bit of transfer action happening over there. So yep, still possible, but just noting that we're aware that there's a transfer structure going on over there. So yep, satisfied that. The first floor should be 5 meters above, the rest are 3.5. Yep, cool. And the 2 meter setback. So we've got two distinct viable solutions. Now we have the task of reviewing and critically appraising the schemes, identifying the solutions, and recommending the reasons for your choice. Now, when you do this, I think a lot of people probably think they're just gonna have like sort of like one really good scheme, one really bad scheme, and then they'll talk about why one's so good, why one's so bad, and they'll just shit all over the other one, and then go, okay, we're just gonna choose the scheme that's good. I don't think that's the best approach. You've been asked to present two like viable schemes to the client. You want to talk about, you want to give two good schemes, and then choose the best one, as opposed to just say like here's a good one and here's a bad one. So I haven't actually prepared that yet, but let's just go through it now. So with our sort of post-tension flat plate concrete structure, what's the good thing about it? I would say you've sort of maximize it's, you don't have any sort of beams, and it's quite a thin floor plate element, so you're maximizing, I'd say the main benefit of this is you're maximizing the floor to ceiling height, which is great. Um, and then a couple of other points I would say for this structure here is the fact that it wouldn't require any sort of, like concrete structures just have um, sort of inbuilt, if you'd say, fire protection. Like they don't require any additional fire protection. You get that through the concrete cover, so that's an advantage for this structure here. And then another one you could say, because it's like a monolithic concrete structure, you get more robustness. So I would be adding, that would be my three advantages. If I had to say some disadvantages of my Scheme 1 concrete structure, I'd say it's probably heavier than my composite structure. So heavier means, and the fact it's all concrete, I'd say it's got higher embodied carbon. Um, it's also the larger mass leads to larger foundations, which is another disadvantage, and it's probably slower to construct. Um, as you concrete takes time to cure and achieve minimum strengths to sort of continue building up. Let's move on to scheme 2. So what are the pros? Composite is generally sort of more efficient, so it's lighter. Steel is faster to erect than concrete. Um, And so one big thing here, and I think if you sort of ignored this, you're probably losing big marks. So the fact that they've said this is heavily contaminated. So I personally prefer designing composite structures, so that's why I chose this foundation system for this scheme. So I'd say like the main, if I'm designing this and I'm building this, I really don't want to deal with that contaminated. Like I don't want my site team, it's a safety risk and it's also a huge cost to even sort of excavate it and dispose it anywhere. So any foundation system that can sort of make me not deal with the contaminated soil is a big pass. And that's why I've chosen the driven precast piles. So I pretty much grab this pile and I drive it straight into the ground. This is before anything else is there. And I just get it and I drive it straight into the ground and I don't have any spoil. And sure, there's going to be some site controls there, but that's how I'm getting down to the better quality soil as opposed to my board piles. And obviously, I haven't even suggested any pad footings because then you have to excavate that stuff up and dispose of it. Whereas the driven precast piles just go straight past it. And that is probably the main advantage and a huge cost saver for this scheme here. On top of the things, like another big point that so they've asked our opinion as well, and embodied carbon and sustainability is going to be one of my big um, sort of influences on which scheme I choose. So composite structures, yeah, they're efficient. I don't know what all the sort of carbon equivalent or rule of thumbs are for the different floor systems, but I plan on learning those and using that to sort of guide my client to the preferred system. So that's all I have. I haven't actually done part B yet. It's just a little letter. Can't be that hard. Um, yeah, cool. I hope this helped some of you guys and girls out there. Thanks. That's all. If you liked, give it a like.